the edge of the handle.
Yeah. Okay. Let's see. We got a couple minutes. We'll wait another 2 or 3 minutes just see if anybody else shows up.
So loft 18. So something's wrong between loft 14 and loft. Oh my God! It dependency found from loft 14 to extrude 83. What does that even mean? Where? Extrude 83.
Yeah.
There are many more. That was a while ago.
Yeah. I mean, your timeline is so complicated. Like, you're not going to be able to troubleshoot that literally. Like you're not going to.
My last one was 97.
You need to like finish a part and then like derive it into another.
Well, right. Like we talked a couple times briefly. Have multiple pieces that come together to make a whole model, and in this case, like creating this part as a separate part with the features, and then creating an assembly that adds it back in. A lot easier for Fusion to do the math that you're trying. When you have a timeline like that, and then you try to make sure that like 20 features in it, you're getting calculate. Let me show you. If you click on like this line right here.
Oh, okay.
The radius of that is, yeah. So if you know that, and you can probably, let's see, this is probably a way to figure out the length between the end of this sphere and the end of that sphere. But create a new model, create that cylinder with the rounded ends. All right, let's pause. Let's pause on this though. Let's talk about some of the other stuff. After we.
RC car.
Yep. So after we cover a couple of things, we'll get back to working on our stuff independently. So. Yeah. Well, so it balanced for a little while. It's gone through a couple of iterations, and then I moved on to something else. So. Yeah, we're going to talk about that. All right, so let's focus over here for a sec. So there's a couple things that I sent out in the email that I want to talk about. And we'll kind of decide, kind of pick and choose a little bit, and I'm going to go back. Because this is something I do all the time. And since there's only a few of us here, actually, we've got enough stuff that we can all kind of pull something apart. I've got a couple of examples here that I like to use because, I mean, sometimes it's sort of like it's a mystery what you're going to get when you pull something like this apart. And a lot of it is fun. I agree with you. And a lot of the inexpensive electronics, like there isn't really that much that you can harvest because stuff gets so integrated. Like you get tiny parts that are soldered onto circuit boards and stuff like that. But things that have mechanical parts that move, like RC cars, usually have some stuff that you can pull out, which is kind of cool. And these cars here, this one is broken. This one is brand new. I got these at Five Below. So it's an RC car for $5. Like, you know, you can't really beat that for a price. So we'll pull these open and see what we can get out of these. I know for a fact that there's some good stuff in here. And then this, in the office over there, for the guys that do software development, they have the desks that raise up and down. They're like the standing desks. And when one of them came in, this is the control module. There's like a little panel that has a bunch of presets and then the raise up and down thing. And then this is like the brain that goes between the control panel and the motors. And this one was bad. Like when it came in, one side worked, like the raising up and down motor on one side worked and the other one just didn't. Yeah, well, you'll be interested to see what's inside, I bet. It's got actually a little weight to it. But anyway, so Andrew contacted support and they just mailed him another one. They didn't even ask for it back. So like they didn't want to troubleshoot it, fix it, or anything. They were just like, yeah, whatever. Here's the part. So, but the interesting part is that this thing, the job of this thing, is to take a signal and then control some really powerful motors to make the desk move up and down. So the stuff that's in here might be very relevant to robotics. So we should take a look at that. So anyway, why don't we pull these things apart? And see what's inside. We'll talk about what we could steal and use in other projects directly. And we'll talk about what we might be able to look for in other things. Do you want the big thing? In the screwdriver kit here, you got to kind of hunt around. But for the cars, you'll probably want small screwdrivers like these. Can you figure out how to take that apart? If you can, try to take these things apart non-destructively. If you break something, it's not the end of the world, but flip it over. These are rubber.
Those are normal.
When you say normal, you mean like normal size? Let's see.
That's number 2. Okay.
He might have the one over there, but there's probably also, yep, there's switchable bits, and you get the, yep. So anyway, so there's stuff that directly. There's also kind of flipping that around and trying to think about where you could look for parts if you need specific parts. And there's going to be things inside like motors, for example, that we could use in robotics projects. But also taking stuff like this apart is a really good way to learn about mechanisms that are commonly used in these sorts of things. So for example, in both of these cars, they have articulated steering. And that frequently uses like something like a motor or a servo, a single one. Yeah, to like you have one source of articulation like a motor or servo that is using a linkage to move steering on both sides at the same time. And so you might be able to borrow steering parts, but you like at this point that's also the kind of thing that you guys would be capable of modeling. So you could create models for those parts in Fusion, print them out, and reproduce them in your robots. So these sorts of things are useful for getting ideas on how to build things, as well as where to harvest parts directly. Also, we can drive them around.
That was not the right place to open.
How do you mean?
Battery's not.
Oh, yeah. How do you get it apart further?
There's this.
Is there a look on the side here? See it? Nope, underneath, right down in there. Little tabs. What are you missing?
Number 0.
Cool. So, Drew, what do you got going on over there? Screws under the caps?
Yeah.
Cool.
This is entertainingly pertinent to what I was doing this afternoon. Because my brother, when he and my dad were moving his stuff back from college for winter break,
Yep.
they managed to break his monitor.
Like LCD?
Sadly, nothing in the monitor, the actual panel.
Oh, geez.
So he's ended up getting a new monitor. But I now have the broken one.
Let's see.
It costs nearly as much as the monitor itself, like $100 less.
Oh.
Just buy a new panel.
Yeah. So it's the actual panel itself. Like, does it have a crack in it,
Like,
or?
right in the middle, there's just like you don't see when you turn the screen on, but as soon as you turn the screen on, it looks like a bullet went in.
Oh, geez.
Like it's a heavy fracture.
You might be able to get some interesting stuff out if you're not going to repair it. So, like, depending on how old the monitor is, the backlighting, like they use different technologies depending on how old it is.
Relatively new.
Okay. So it's probably.
Curved 140
Oh, wow.
hertz monitor.
That's a nice panel. So there's probably LED backlighting, and so sometimes it's strips that run around the outside of the LCD panel itself with a light diffuser, so that the light comes through the panel, so you can see the image. And sometimes you can harvest that stuff. You can probably also harvest the power supply, but that gets a little dangerous depending on if it's an external power brick or if it's like.
Did I take this whole thing apart?
Yeah, take it apart as much as you can. How you doing, Jaden?
to get something under bed.
Yeah, try a smaller flathead, like one of those.
Oh, that's a flathead.
Yep. There are little ones of those too.
Okay. Motor.
Yeah. So what do we got? You got.
Other motors.
So that's like all the circuit board looks like it's in one
Yeah.
place, and that's obviously the motor that's driving the.
So is this an H bridge?
That might be, although if I had to guess, I would say that is probably a complete RC car controller, all in one chip.
Yeah.
Because they can make that super embedded and super cheap,
Yeah.
and then
I can imagine.
they just solder it onto a board and it's ready to go. Like there's a company that designed that, and then they sell them for 3 cents each. And whenever a company in China needs to make an RC car, they order that part, and then they build that board, and then it's the whole solution all in one. In fact, I didn't look, but so see on the box here for the one that he's taken apart, it's 27 megahertz. That's the radio frequency that it uses. If you go to Five Below, there's a whole bunch of these RC cars that all operate on that frequency. I bet you they all use that same board. Well, a lot of times they sell two. There's like a 27 megahertz one and then like a 49 megahertz one or whatever. And so if you want to, what's that?
Quality control pad.
Nice, good job. Good job, manufacturers. So if you and a buddy want to race, you have to get one for each frequency so they don't interfere with each other. Because I've had that thing before where I had two of these identically, and you move the controls on one and both cars move because they're using the same circuit. It's hilarious, but it's not useful,
So what do you think we could actually do with this small chip?
Well, that's a great question. So do you remember the conversation that we had, this is like 2 months ago now, when we were talking about transistors and switching,
Yes.
right? So the job of this thing is to receive signals from the control, and then it outputs enough voltage and current to move these motors. But if you instead use the output that's running to the motor to energize a transistor or a relay, then you could use it to switch something else on and off, right? So like maybe you want to switch a larger motor on and off, or maybe you want to, turn something else on and off, like a light, or maybe you want to, signal something on anything you can think of that would require turning something on and off.
Yeah.
You could keep the remote, harvest the board.
And I'm guessing this isn't complex enough to actually provide like a ramp for how fast this thing goes.
Well, you could put batteries in it and find out. If I had to guess, though, I would say probably not.
Yeah.
Yeah. Why don't you bring that over here? Bring that over here so we can all kind of, have it.
This is the big one.
Okay.
There's
Oh,
the one
geez.
huge one.
Yeah, okay, so,
Oh, exposed.
yeah, so this is taking AC power in, so actually we got to be careful with this. I don't know that, it hasn't been plugged in, and it hasn't been plugged in a, over a year, but still, let's,
Anything grounded?
well, I can short out the caps. Don't try this at home, kids.
If there's anything in them.
Putting that capacitor
Yeah, there we go.
really bad.
Yeah. So there's nothing in, and then that one is discharged. Discharged.
Someone must like
Okay.
on their arm for like a week and a half with like a one like
You don't have to answer that if you don't want to. Oh, okay. At camp?
Yeah.
Wow.
It was a guy.
Oh, I was thinking like scouts or something. It was
No,
like, that's a
I was
particularly
wel-
nerdy,
I
like,
was welding there.
yeah? That's cool. All right, so these are all discharged. But so this is taking power from the wall. This is an AC cord, right? So this power supply is there to provide the power for the motors and the control board for the rest of the desk, I'm guessing, because there's no other power source. So interesting, because we'd have to hook it up to a meter and actually measure it to know for sure. But usually, if you've got something like heavier wires like this is like a higher current output. And so we could fire up the power supply and measure off of these wires what it's putting out. Now, sometimes the circuit board will be labeled and it'll say 12 volt out or 24 volt out or whatever. I don't see anything like that. The most common things you're going to see actually, on the circuit board down here, these aren't the high output labels, but we've got 5 volt, 12 volt, 5.7 volts. That's a weird one. And then ground.
It's like the same voltage is used in like low-level airsoft gun batteries.
Okay, that's a random bit of knowledge you've got there, but sure. You know, in a computer power supply, you're usually going to see 5 and 12, sometimes 3. You know, so there's a bunch of different outputs here. So you could harvest a power supply like this and use it for other things, which would be kind of cool. Now, anybody know what these black boxes are? These are some of my favorite parts. These are relays. So if we were to desolder those, we don't need to, but if we were to desolder them, they would, oh, I'm getting heatsink compound all over my hands from the power supply. So these, if you pulled the plastic cover off, would look like this. Well, we might have looked at this back when we were doing the switching discussion a few months ago, or a couple months ago. But basically, it's an electromagnet, and it's just moving the switch contacts back and forth to activate and deactivate the switch. So these are what the little control panel is switching to move the motors up and down. So these are great. Like, if you need to buy these, you spend a few bucks each on them. So you can desolder these and reuse these, and these parts last forever. I mean, it's a big mechanical switch with a magnet in it. There's not really, unless you use it improperly, nothing that's really going to wear out anytime soon. One of these might be bad. The control module had a problem.
I see actually if they are bad, because what if like one is just bad and then we replace it and the whole thing works?
That is entirely possible. Why don't you hop on a computer or whatever, look up one of these part numbers and see if you can find a scheme. Oh, okay, cool. Yeah, sure. But let's look up those part numbers. If we can find the pinout for it, then we can figure out where we would need to apply some voltage and see if we can get the relay to work. What's that?
4 hours and 30 minutes.
Okay, yeah, that's a long print.
828 grams. So it's basically a roll.
So Jayden, this is the one you opened up, right?
Yeah.
Okay, cool. So this looks not identical, but very similar to the control board that Yorgo has in his. This is very close to what's in yours. It's interesting, though. It's got a couple of other chips that you don't have. I don't know what those are for. I'm really interested. This is a little bit unusual. What's kind of cool about these cars is... What's that? Oh, you're finding something? That's great.
That's what was holding it in.
The screw? It kind of makes sense. So what's interesting about these RC cars that I haven't seen in other ones is these are both DC motors. Like, these are regular old, hook them up to a battery.
There just be a servo?
Yeah, or sometimes there's not even that. Sometimes there's just a magnet where it like pulls the steering one way or the other. But this has 2 full motors in it. So we could pull these motors out and use them for something else. Also, it looks like you have the same arrangement that Jayden does here. The motor is driving some sort of gear reduction. Why don't you see if you can get that open, and let's see what that looks like inside, because that might be something else that we could use. It might be oh, okay, cool. All right, so what do you got going on here?
I pulled apart the controller.
Yeah, so these are,
Directions.
yep, they're buttons, right? They're little switches. So these are parts that you could desolder and use for something else. So this is, the same. This is what they call like a momentary switch, where you push it, it does one thing, you release it, it does something else. Unlike this, which flops back and forth and it stays in that state. These, I got a whole bag of these. They're useful in projects because, like, if you want to, like, if you're building something with your Raspberry Pi and you want to trigger an action or a response or a state or whatever, these are really easy to use. So these are totally harvestable, and it looks like the whole control board is built just with that. What's the middle button for? Yeah, I didn't even see that on the control. What is that? Does it say what it does?
No. It's a $5 RC
Yeah.
car, but
So what is it? What is that supposed to do? Does it say on the? Maybe you should put batteries in it and see what it does. Here, have batteries.
Do we have a bigger screwdriver?
Yeah. You don't have to put it back together. You could just put the batteries in, power it up, and see what that button does. I'm kind of curious to know. Like, it's just a random switch in the middle of the controller.
I know.
Get this thing back in.
I wouldn't even bother. I would just, the batteries go on this side.
Oh yeah.
One of
So
my
just put the
cousins
batteries in
that's
and.
younger got a RC car for Christmas, right? Like basic RC car, and something that was very interesting was it was set up for not arcade drive. It was set up for tank drive,
Okay,
and so you
that's
could
interesting.
both forward or on the top of it there was a switch. Very odd to not
Yeah, that's sort of strange
idea.
design. Oh yeah, yeah, big power resistor. It's got to dissipate a lot of heat, probably.
Okay, so yeah, that's the gears.
That's the
One's already fallen out.
200-volt capacitor.
Yeah. Where the coil, the magnet coil pins are, and then we should be able to try to trigger it with a couple of alligator clips or something.
It's gonna be difficult to put back together. Okay.
This is correct.
So you gotta like hold that.
I bet you can do it.
Yeah.
What's that? Okay. So the two that are by themselves, right?
No, it's this one and this one up here.
Oh yeah, coil. Okay. That's weird because this is like 1, 2, 3 and coil, and then on the diagram, the two that are by themselves are not the coil, and that's kind of dumb. Why did they do that? Anyway, so and then
Good question.
what is the voltage? 5-volt 5-pin relay, or does it say on it?
24 volt.
Okay.
So what's like there's RJ45 and there's
Doesn't seem to be doing anything.
I think these connect out to the motors. Although you could go look under one of the desks in there if you want to.
There's this layout that's like the actual part that doesn't like tell you.
Did you power up the car?
It just has like wire locations to tell you
There's a switch.
This is left and right.
There's no switch to turn the car on and off?
that one says LR.
Off, on?
Oh. It's for the like buttons to raise and lower it.
Oh, okay. So there's one connection that goes to the panel,
Yeah.
and then another one that goes to the.
One in the middle just drives it forward,
Oh, okay.
and does the same thing as the
Please
one.
let me search.
So that's what you were
So
just
these
describing?
two buttons do the exact same thing.
That's brilliant.
Alright.
So why don't you disconnect these wires so the board's separate from the power supply, and let me see if I've got a couple of alligator clips.
Real question is, I have a PDF one, but that doesn't show up on the actual site. Look at this. It's the same site.
Yeah.
They have a PDF here,
Yep.
but you can't actually find the product.
Oh, maybe it's discontinued or something? That's a little strange. Let's see, I never shared the stream. Not that probably anybody in Discord is paying attention, but let me just share that before I.
So what exactly is this?
Oh, I'm going to talk about that. That is a robot that I designed and built, and we're going to be using it in another short session that's going to start up in early February. Let me just paste this link in, and then I'll explain it a little bit more.
Why is there just like a circuit board down here by the computer?
It's a Raspberry Pi. I think Ilya was using it, and he forgot to put it away.
Oh, I saw some really stupid ones. This got like a million USB headers that like could plug into another USB, and they just like piled them out. Like they just like plug it into the top one and plug another USB in. And so it was like 14 of the USB headers.
Big brain
stacked.
time.
So one USB
Jeez.
Guy.
Okay, so let's go a little deeper on the
Take a full year to try.
Oh wait, yeah, I should actually take that apart too.
yeah. So Jayden, so on yours, how do the directional buttons work? So the steering does move the steering left and right, right? But with the forward and back buttons on the controller, is there no difference between?
So
Some of
the
them are
back one goes
transferred.
back, but these two do the same thing.
Do they do it at the same speed?
Maybe.
Like it's kind of weird
I
that there's
think.
only
Super.
like is
it's a
it like a turbo
$5
button? Yeah, I know, but like understanding like what the thing does is sort of important to know like what you can do with it, right? So try the I've got it off the ground here. Go forward just with the regular forward button.
How much you want to bet this?
Are you?
batteries are.
Oh yeah.
Isn't even
What'd you do?
actually held in place. It's just gonna slide out.
Okay.
Cause that's what I'm thinking. I'm gonna pull this out and it's just gonna slide on.
Okay. Oh,
Oh, that one does it fast.
yeah. So speed difference. It's like turbo fast or whatever.
And then that one's.
That's actually pretty quick. Like that's moving pretty good.
Oh, okay. And of course
Just go forward regular speed. That's pretty quick. That's not bad. That's pretty good for $5. So okay.
Okay. So it moves basically how a steering works.
Take the steering part apart. The front section there.
It works just like a steering wheel.
How do I? Wait,
So-
let me see if I can figure
Yeah,
it out.
take your time and
Off.
experiment a little bit. I don't know. Look
So
at the
these two
look at the
sit
switch.
here, and then the motor moves it side to side because it's got little teeth on it.
Oh, so it's got like a rack gear.
Yeah.
And,
then it's got a spring right here.
Okay. Is this the steering motor?
Yep.
Is this the? Okay.
So that just sits in there.
Yep. I wonder. Okay. Oh, so the sat like that, and then the
Yep.
spring on the underside. Okay. And what's on the underside of the chassis here? Oh, it's so you can
Offset.
tune the
Yeah.
steering. That's pretty cool.
Yeah, I've seen a lot of them have that.
Yeah. Like somebody put some effort into the design of this,
Oh.
and then just like designed it down so that they can produce it, and
Efficiently.
yeah, and then sell them for $5. Oh, really?
On
This one, like, if you look, they're like coming up from the underside.
Yep.
There's some. And there's
Yeah,
some on this
that's
dude.
a little-
There's some marks there.
a couple
Yeah.
months ago, our washing machine
Mhm.
like stopped working completely.
Okay.
We tried running like a diagnostic on it, which I didn't even know washing machines could do. But that didn't do anything for us. So my dad went in, he like took everything out, he made sure water was going to it and everything. And he said to pull out like the motor controller. Open the motor controller box and the whole thing is black.
Oh, geez.
Like something just completely
Well, sometimes what you get, yeah, like this one doesn't look that bad, but sometimes what you'll get is one component will fail, and if it's something important like power regulation or something like that, yeah,
something
everything else
yeah.
that's behind it will just melt. And some like really well-designed circuits will have protections to prevent that sort of thing. But a lot of this stuff now is just disposable, so there's no reason to do that. There's nobody that you're going to take this to service it. It's just throw it away and replace it with another one. So do you want to try to trigger the? Do you think you know which ones the coils are? Like, do you think you can trust that?
I think so.
All right. Let me see if I have anything that's close to. We got to be careful with 24 volts. Because that's actually enough to potentially shock through your skin. Oh, we should try it with, because a lot of times you can trigger with a lower voltage. It's just out of spec. So you got it open? Yeah. So take a look and see if that's the same setup as Yorgo has in his. Okay. So what we're going to do, why don't you bring the relay board back over here? So the pins for the magnetic coil shouldn't have a polarity. I didn't check this with a meter, so I don't know if this has any charge in it. But we're going to have to be a little careful. Like, you know, we don't. This is only 12 volts, so this wouldn't shock you. But if we arc it together, it could damage the battery. So which pins do you think it is?
I believe since they go like this way because there's the 5 here. I believe it's.
Those two? Do you want to try, or you want me to do it?
I don't care.
All right, let's listen for a click. Nope. Nope. Let me make sure the battery's not dead. I have a bunch of these batteries in varying states. I grabbed the first one I saw.
Yeah, apparently, whoever cleaned out the lab,
Yeah.
they managed to somehow leave like a freshly boxed multimeter just on the shelf.
Oh.
And I was like walking by the guy who we got the lab space from.
Mhm.
He was like, and you put it back. This didn't happen.
Okay, that's probably way under spec. So this is supposed to be around 12, and it was 7.4. So let me see if I can find another one. Yeah, one of these should work. One of these is still good.
It also looks like some of the thermal compound stuff almost like kind of de-solidified a little bit
Okay.
because it made looking at it weird, but everything else is like really smooth.
Mhm.
It's like this one on this thing is just like kind of jagged a bit.
Yeah. Okay.
Also, who just leaves a little like tiny like line?
Sure.
Yeah, it's pretty much the same mechanism.
Yeah.
Idea, at least.
That'll do. All right. So we think it's the ones on opposite sides of the pin. Yep. Nope. That should not have done that. Yep. That was arcing.
Fantastic.
So, I mean, that could indicate that that relay is bad.
So what are we trying to do? Like which ones are we aiming to?
The coil ones.
Yeah. So which ones did I?
So coil 1 and coil 2 together.
I did these, or okay. So let's try these over here. I'll try this at home, kids.
So yeah, coil 1 and coil 2. Yeah, those the ones that you were just touching. Yeah, those two.
They are not actuating.
Reversing polarity.
That was arcing and making the wires hot. Nope.
That's why they got plastic around. Oh, that works quite a lot.
That didn't sound clicky to me. That sounded like arky to me.
Sparky.
Yeah. So it could be that we've got the wrong.
Maybe.
C and NO.
10 amp. Oh. Wait. 12 amp, 125 volt AC. These are. Oh, no, that's the switching. Okay. Yeah, these should be actuated by 24 volts.
What were we hitting it with?
12. Okay.
Yeah.
Yeah, I mean, the other thing we could do is we could relay. And there's a chance that on the underside, like sometimes there's clips, and we could open it up and then see what it looks like inside.
Should we try that?
I don't know. Do you guys want it?
Sure. Sure.
Okay. Why don't you fire up one of the soldering irons?
I do not.
What school?
Technically none.
Really? You're in, like, is it an independent team?
It's sort of, kind of. The school like
You okay?
started so we
Yeah,
could
I'm
get
good.
the
It
grant
left
from
the
the
complete
Department of
opposite way
Education.
where I was.
They have no other involvement.
Okay.
Apparently, the last time they took all of the remaining grant money and
Yeah.
gave it to like the track team.
That's lame.
Yeah, for like track jerseys or something. So now our running joke is we have like whatever the sheet of like the thin sheets of like aluminum metal or whatever, they're like really loud when you shake them. It has like all the old sponsors on them.
Mhm.
You can hold on and be like, we have none of these sponsors anymore. There's a high school sticker on there. Which is also why we meet at the high school.
Gotcha.
Because they were not willing to offer us space there.
Mhm.
No.
Hmm.
Yeah, how are you guys with like funding?
Oh, we're fine for funding.
Oh, okay. Because my team almost like didn't have enough money to do the
Also,
registration.
because we're a rookie team, so the registration gets like covered by the. You got like 7,500 from FRC.
And
They should just give you 2,500 and waive the registration cost.
Yeah, like that's.
Because the registration's $5,000.
yeah, it's really.
So, is the team at your school a new team, or was it already
we're
there?
3 years, so we're decently into it.
Yeah, cool. Is this your first year?
No, I've been here since the beginning.
Okay, cool.
We're a rookie team with the parts backlog of a like decade-old team. Because it went for a while because we whatever I don't know what number we last number was 34.99.
Oh, we were 71.26.
Exactly.
And last year we saw teams in like 10,000s. So it's
At
like
the
growing.
kickoff, I saw a team that was like
20?
Like 2-0?
yes, like 2 digits.
That's long running.
I'm
But
pretty
it started in New Hampshire,
yes,
didn't it?
I'm pretty
So.
sure. I would assume the number 1 team would be somewhere in Bedford because that's I think where the like.
Interesting.
I assume it'd be somewhere in Bedford, but
I wonder.
unless a team managed to beat Bedford's school to registering for something started in Bedford,
Yeah. I wonder what the lowest still running team is.
I would not be surprised.
Is there a lookup? Like, can you go on
Oh,
the
yeah, you can
FRC
look 'em
and
up.
I wonder if there's a like, or I wonder if you can like list all, sort by number.
FRC team.
Yeah. Yeah. Right. Okay. So good job pulling these apart. So if it were me, I would be harvesting the motors for sure. Like that's the obvious
Oh,
thing.
yeah.
I would probably keep the wheels because wheels and tires are always useful. The control board with the remote is definitely something you could reuse, although that takes a little bit extra work. You'd have to do some stuff with electronics, like soldering in a transistor or something like that. Yeah, there is. Well, we never fired this one up, did we?
I don't think so.
Yeah, there is an LED on it here. That's kind of interesting. The battery pack you could definitely harvest. You could cut this right out of the frame, and then use the battery pack with the wires. I don't know if this rack gear is super useful, but
yeah, we could definitely like probably 30.1
Mhm.
a bit bigger.
In Pontiac, Michigan.
okay, weird.
Michigan, number 1.
Their rookie year was 1997. I don't think I think that is the year FRC started.
Okay,
There's a bunch of like unclaimed spots in here.
yeah. The other thing that's kind of cool.
How is the first team like? It takes till number 19 to get a team like inside of New England.
Yeah.
Which is weird.
Yeah.
Yeah, when we go to competitions, we usually see like some the lowest number we've seen is Team 69 in Hyper. Seen that one around.
That's pretty low if they're in the 10,000s now.
Yeah, and then there's like 230 something obs,
Yeah.
and then the cheesy poofs are also too low.
The cheesy poofs.
Yeah, we all laughed about that one. They've made a lot of robots. Like
Yeah.
they have a website and you can click through.
Oh, like the history of the robots.
There was some team at the kickoff that literally had like 40 kids.
Oh yeah,
The one from Newton, Mass.
Okay.
What color were they?
They were the Liger bots, so they're all wearing like bright orange.
Yikes.
Yeah.
There was like so many of them.
An army of orange
It was
kids.
like a problem because there were so many of them.
How do I
They
do
all
that circular
wanted to be in the
thing?
same spot, so they all
Yeah.
like crowded the hallway because the hallway was not.
You couldn't even fill the area.
Go to create. Sorry, modify.
That's so they can go to like multiple competitions at a time. Because some of the I see videos of like
It's weird. Oh, pattern. Pattern. If you go back up to the pop-up for that option, it actually describes exactly how it works, which is one of my favorite things about Fusion. So hover over it for a second. So that's a feature like you were doing with the dimples, and then you specify an axis and a quantity.
A lot, because the kids are still like basically the same except for the ones that graduated. Except our mentors have switched every year. Because our first two mentors that started the team both left the school, and then second year, only one mentor has stayed from that year, and now we have a new one. So.
Joke's on you. We don't have teachers as mentors.
Yeah, you don't exactly need that.
Oh no, we'd be perfectly happy to have them. But you know.
Yeah.
Michael and I are happy to pitch in.
Yeah, the
So.
school doesn't like us.
That's all right. You'll win, and then you'll get attention.
Yeah.
And then they'll steal our money again.
Yeah, maybe. Okay, so here's the catch. So you took it apart, you got a bunch of parts and ideas and stuff that you could harvest. I really like the steering mechanism. This is super simple, by the way. Like, this would be really easy to copy and use in other things. Like, this is totally modelable. Now you got to try to put it back together.
All right. That's not hard for what I took apart. Like 5 screws and pins.
Jaden, when you get to a pausing point, try to put your car back together.
Yeah, this shouldn't be too difficult.
It should be doable.
Oh, yeah, for sure.
Jaden might have it a little bit more difficult because he's got plastic clips rather than screws. As long as everything goes back together without breaking, it's fine. But I vastly prefer things that go together with screws.
And last year we were like completely against our school, because we worked inside our school. But still, they didn't help us at all. Like, they did the opposite of helping us last year. Because we bought a
They
laptop.
sabotaged you?
I don't think you can get worse than ours.
Yeah.
We bought a laptop, right? Like a nice Dell workstation laptop. Like, I think it was a new model. And then the IT department, since we were inside the school, using the school Wi-Fi, they took our laptop and they loaded like an old version of computer, and we ran into a bunch of problems because and the school computer didn't have the privileges to download the drivers. So yeah, we ended up like one of our giving it to a friend of theirs, and they just wiped the hard drive. Just wiped the whole thing clean.
That's disappointing that they couldn't come up with a way to work around the, whatever restrictions they had. Like,
Oh wait, I just
Or just
forgot.
leave it alone.
Or-
well,
I just remembered I didn't put screws.
well, if you want it to stay together, that might be helpful. What's that?
I just jacked one of the laptops we have in our basement.
Oh, yeah.
Dad's old work laptops. And
Yeah.
it's like when he was getting like really strong laptops or whatever.
Mm-hmm.
Like there's like a Quadro in it.
Oh wow.
Jeez.
They give you what's basically like in the box of the rookie team. They give you what's basically a glorified Chromebook.
Okay.
Yeah, it's like.
Oh, they actually give you a. I mean, not that you would want to use that. It sounds like, but
For
like.
anything you would do with robotics, it doesn't qualify as a laptop.
Okay. But is it like, does it meet some minimum specs for you to be able to like program the controller or something like that, or?
Barely run like Fusion
Yeah.
on it.
Well, yeah, like yeah.
It took like 2 minutes to open Chrome.
Oof.
Yeah.
We
Yeah.
also, when we were going through the old stuff, we found some.
Crash. No. Don't crash.
Don't panic.
We found some old hardware.
Yeah.
We found a laptop from a company called PC to Go. Intel had a minute.
If I hit OK right now,
Yeah.
it's probably gonna die.
Just expect the worst and be happy if it doesn't happen.
Okay.
It's all about expectations and the mindset.
Getting okay. Computing
I mean, you can also speak nicely to it, and and see if that helps.
Computing like 16 different lofts. and
You'll get there someday.
like
Yeah, this year we actually
it's dying.
man, we were in such a predicament last year because we were we were able to get some pretty good
Yeah, that
sponsors
didn't work either.
to get us tools, but one problem we had was we didn't have bits. So what did we do? We went to the wood shop and took the wood bits and used them.
Yep. On the aluminum. That just
And it
deleted the
just-
whole model.
Oh yeah,
too.
one time one of the
Okay. Well, we'll figure something else out.
shop people walked into one.
Actually, not.
No, it destroyed the blade
Okay. All right.
completely.
Well, so there is sort of precedent for using wood tools on soft metals. Like you can use a chop saw, like a wood cutting chop saw, to cut aluminum channel, and it does wear the blade out faster, but it's not like going to destroy the tool. But yeah, it sounds like the bandsaw blade couldn't take it.
Destroyed.
Yeah. We
I
have.
don't think it was very thin aluminum.
Okay.
It was like. We apparently have just like an entire pile of like extrusion.
Hmm.
Like there's like a whole shelf of it.
Yeah. There's
That's what I
a
had in my model.
in extrusion.
Yeah.
Oh, you mean like extrusion?
Different extrusion.
Yeah, same word. So the makerspace here in Portsmouth, we had kids from the Portsmouth team come in a couple times when they needed like some fabrication assistance. So we'd help them like cut their aluminum sections down to size and drill additional holes and stuff
Do you
like that.
do anything in the makerspace?
Yeah, yes, I do.
No, he just watches.
Yeah.
Well, yeah, because
Well, I've been a member since the beginning, and I'm involved in the
Fantastic.
like it's a
I did not
nonprofit,
realize this was
so we have a board of directors, and like I'm on the board. What's
I
that?
didn't realize it was magnetic.
yeah, we're planning on using the makerspace.
Good.
So,
That's cool.
We get access.
What town are you in?
Newmarket.
Oh, okay, cool.
We get access to all sorts of UNH things.
Yeah, I live in Stratham, so I'm like around the corner. What's that?
Because we have a UNH student as a mentor, he can get us access to like all the UNH stuff,
That's great. Like-
including the machinist's workshop with the like 4-axis CNC machine.
Oh, geez. I would
it's the
love to have
small-
that.
It's the small one, because in the advanced manufacturing facility or whatever is the like huge 5-axis.
Yeah,
one.
that's crazy. I would love to have access to one of those. When I was working at Berwick, we just had a little tabletop-sized mill, like super small. It was like the size of a 3D printer. But what's that?
In a mill in a high school.
Well, yeah, right. So I wasn't complaining, but like I had a after-school group that was doing some robotic stuff, like not competitive, just like for fun. And so we would, yeah, right. Oh gosh, I'm gonna reuse that. Anyway, so we would 3D model some simple parts and mill them out of aluminum on the little mill, and it was great. Like it had to run it really slow because it wasn't a powerful mill, but being able to fabricate metal parts right there on site was really cool.
Yeah, our team last year, we made a totally smart choice of we got a nice grant for an XR CNC router.
Oh, cool. Yeah.
So we got like super pumped over that, and we ended up.
Yeah.
Oh yeah, our school also managed to. We have to reschedule one of our competitions because our school managed to reschedule prom to the competition, and all but 2 people on our team are juniors.
Oh. If it were me, deciding between, that's
Try not to go with like just the 4 of us.
yeah, right. Yeah, sure. The other thing, speaking of mills and cool fabrication stuff and having access to makerspaces and all that, there is a New England like competitive robotics league that's basically like amateur battle bots. And I forget the name of it. I came across it because I was following the blog of an MIT Mechie, actually electrical engineering / Mechie student, who used to build robotics and power systems and stuff like for fun. Like he was studying the stuff, but he was really good. He started basically memorizing everything he could. his kick scooter, built a whole series of small go-karts and all this other stuff. And he was like designing and building his own brushless motors, and like then he got into the power control system. Now he actually designed like basically a power control board for robotics because there wasn't one that was robust enough for the stuff he was building. So he designed his own, and now he sells it. So like he has a company that does this thing. Anyway, so I followed his stuff. I had never met him until I went to New York Maker Faire in like 2016 or something like that, and I was there with one of my students and their family, and the guy just walks by, and like I had only seen his photo a couple times, but I read his blog, like everything on his blog, and he just has sort of a distinctive look. He's Korean and he dyes his hair, and like and he also he did a bunch of the competitive like go-kart races that they do at Maker Faire, so there was a chance that he was going to be there anyway. But he just walks by, and I'm like, hi, and he got, and I'm like, no, it's not creepy. I've read your blog, I've learned a ton of stuff, like, just thank you for doing the cool blog. And had a bunch of the robots spread out, and he was showing us all the different features. He was like super cool guy. Anyway, he told me about this like Northeast competitive robotics thing because a lot of the stuff that goes into real battle bots is dangerous stuff like spinning motors and like high voltage power systems and all that kind of stuff. Create a segment of the league that was more approachable, especially under. There is a weight class that's like super ultralight, and the robots have to be 3D printed. So nice job. So basically, yeah, but everybody in that class is of that same restriction. So you could design and build robots and then take them to competitions and fail miserably because of building battle bots. And next time be better, and the next time be better. So I want to go and see that at least, like spectate. But that's something that is out there and available. One of the things that is the independent project work, and like this class exposing you to like robot design and building and stuff like that is fine, but like if you guys are interested in continuing it, it's kind of up to you to figure out what angle you want to take. Like maybe you want to do first robotics, that's cool, but maybe you want to design and build your own thing. Maybe you want to put your own spin on it. Maybe it involves AI, maybe it doesn't. Maybe it's accessibility technologies. Yeah. So like there's a lot of different angles, and going and feeling out something like the competitive robotics, not the first stuff, but like the BattleBot stuff is like another angle to look at. You're getting it.
Yeah, I figured it out now, but before I just didn't see how that fit in there.
The real test is if the Jeep operates when it's all back together. What do you think? If you had to guess, Jaden, is it going to work?
Mine doesn't have a test because it didn't work in the first place.
It's sort of like twitched. Yeah. What do you think, Jaden? Do you think that's going to move?
I think so.
So what team number are you guys?
8410.
8410. Okay, so you're not that.
I think that came out of the wrong spot, but
Really? It looks right. I mean, there's a hole there.
no, but I think like I had the other part where it came out through the case of the battery area.
Oh, I see.
Here, so and there was a hole over there,
I gotcha.
and
It'll probably
it's
still work.
coming out a little bit longer, but
Fire it up. Let's see. Did you put the batteries in it?
You put the top
While you were-
back on.
let me just fix this up.
I'll probably get some pretty interesting stuff out of the monitor, though.
Yeah.
Like especially since it's relatively new.
It's got speakers?
I have no idea what's in it.
Okay. Oh, you haven't opened it up yet?
No.
Okay.
Because I only got permission to be able to take it apart.
It's kind of a bummer that it's
Yeah.
broken like that.
And it's like,
$5
because the thing
plastic
was,
controllers, bendy.
like, I looked
my
at
God.
it. Of course, the only place you can buy the panels is on like AliExpress.
Right.
and it was kind of deceptive because it was like $160, and I'm like, oh, that's not bad. And then I look at it, and it's like, $210 shipping.
Ouch. So how much does the replacement monitor cost? Like
So
if you're
to buy
going
the monitor again is $350. So
Okay,
it's
alright.
basically the cost of an entire new monitor.
right.
So wait, what are the specs of said monitor?
1080p, 144 hertz, 1800 R curved,
What's the diagonal? Did you said what the diagonal measurement?
27 inch.
27. Okay.
I'm surprised. I got my monitor on like Black Friday for, I think it was like 250, and it's 1440 1080 at 24 inches. Yeah.
Larger monitor price jacks very quickly.
Oh no,
Have you seen the stupid? I think they just released it at CES. I don't know if it's actually like a for sale product, but it's like a proof of concept. It's like a, I think it might just be 1080p or something, but it's like 360 hertz.
Oh geez.
Oh, wait, yeah, I saw that.
And then there's also the thing that's like the monitor that is literally like your entire vision.
Oh yeah, right. What graphics system exists that can push 360 frames per second?
Only quadros.
Okay. Like not anything that like a gamer is going to have. I mean,
Not unless you got
Well, and
got
like-
some kind of crazy job.
well, not only that, but like aren't a lot of games frame capped at like, 200 or 250 or 300 or something like that?
Some games have like frame rate things, but a lot of them have an unlimited option that just kind of
Okay.
lets it run wild.
You can play Tetris at 360 FPS.
Play Minecraft without shaders at like
Yeah.
600.
That's going to be
also
the
great.
benchmark for
Yeah,
like
it's-
new.
With shaders and
With shaders, it goes down to like 140.
Really? Super
But it
optimized.
looks so much better.
It does. You can also make it look really weird because you can change how the light works. So the light is like white, even though it's coming out of like a flaming torch.
Oh my god, that's
Isn't there supposed to
disgusting.
be coming like ray tracing in Minecraft?
Yeah. I technically don't have a card that can do that. So I have a 1080 Ti, so it can kind of just horsepower it,
Yeah.
but it'll kind of crush the game in the process.
that thing doesn't even have a discrete GPU. It's like a 2400G. Like
That's
a
'cause it's a Super.
Okay.
it's a what?
That's
Yeah.
'cause it's a,
Yeah, I mean it's got a slot. I
the
just
only-
didn't
the only
populate
purpose
it.
to it would be the NVENC encoder.
Yeah.
But you don't do anything else while streaming.
Yeah.
It does.
Nice. Good job. All right. Successful
Now
reassembly.
don't drive it off the cable and break it.
This was actually a temporary house. Did I ever show you the case design I did?
I don't know.
So I haven't built it yet, but I did a model where basically it's a custom small form factor case the frame is mostly aluminum extrusion with aluminum front and back panels. And it's got a center support so that the motherboard and the power supply can mount on one side, and then a riser cable and the GPU on the back side. And the whole thing is probably like, if you compare it to this case, it's about that tall and about that wide. So it's like super small form factor.
Is there like a company that makes suits?
Zotac, whatever it is. I don't think they're
There's a
that
bunch of stuff.
I don't think they're that small, but it's like
Still,
It's like-
batteries.
maybe this tall. It's like really thin,
Mhm.
but then they're like 7700K and like 1070 or something.
Yeah.
And like
Yeah, right. Well, so like there's a bunch of like, boutique case designers or like ones that you can like crowdfund or whatever, but you end up paying like, $200 or $300 for a super small form factor case. And like, I was like, wait a minute, I can make all of this stuff. So I did a design and then I got this case, which was like $60, as a place to put all the parts until I get around to building the case that I actually want, and then I'll transplant everything over. But so it has one PCIe 16X slot, so I could either put a discrete GPU in it if I wanted it to be like a portable gaming rig, or I could put an encoder card in it if I wanted to have it be a dedicated streaming rig. But the monitor on the side, like basically we did a live stream when my friend was building her new gaming PC. We built it at my house, so I just picked up this whole thing with a monitor and everything attached to the side, brought it home, set it up with a webcam over the table, and we did like a 3-hour build where we put the whole machine together. So it's like, great for that kind of thing.
Wait, when you rebuilt the Jeep, did you put the spring back on
Let's not answer the question.
Yeah.
Android is beefy. It can run Arc Survival Evolved at full settings.
Yup.
Did you hear his question?
But
He was laughing because he asked you a question and then you went into your computer specs. So he was asking when you put the Jeep back together, did you put the steering spring, the centering spring back in?
yes.
Okay.
Okay. Here's the question: do you play modded?
Arc.
Yes.
That's the dinosaur game, right? Okay.
Yeah, no, I don't think I can handle that.
What are you looking for?
But my-
You missing a
Nothing
battery?
Can handle that.
The remote.
Oh, actually,
The
you.
remote would work, right?
It might, but I'm not sure that car worked in the first place. Have you tried turning it on?
Wait, what
Okay.
kind of mod?
One of my RC was broken,
Usually.
which actually makes it ideal for parts harvesting. That's
Oh wait, yeah. No, my computer.
Okay. We need a battery.
It can handle it.
just borrow one, or I can scavenge another one if you want.
Yeah.
It takes like 20 minutes to load like 5 mods.
It's the thing of the more you get
You know, try this.
painful systems in the game.
But as long as it takes like 20 minutes to download.
You can try them both.
No, like
One of them.
Eco's Garden and Ferrari is just.
No, I'm talking about like
Your engine at the bottom of your car.
Prometheus and stuff like that, where the mod author just stopped caring and just slapped as many visual effects as possible onto the dyno. And so you just see it, and you know it's there because your frame's just like cut in half. And then you tame like 4 of them, and then you have like 0 FPS at your
That's
face.
hilarious.
Hey, it's a great way to stop
The guy in the
coming
It's a great way to stop
And
people
that
from
dino in
playing.
the Arc trailer, the one with the head glitched through the tree with like on lowest settings. That was the best computer playing Arc.
Arc just like melts computers.
So you were asking about this
They
before.
Diplo with his head through the tree, taking a bite of air, and the tree falls over.
So I know I posted a couple things on the Discord about this, but I can't remember exactly what I said. So did I explain the concept for this? So Michael and I were talking about what we want to do. We're looking for kind of new ideas. And for the next round, like so in short classes more like instead of this is how skills you need to build your own robots,
Oh, yeah.
more of like a what's that?
I might do that one.
Cool. Like yeah, like a challenge-based kind of thing. So he is doing a problem where they're analyzing. Basically, they have all the demographic data for all the passengers on the Titanic, and you can build a data model using something like a neural network or other techniques, algorithms to predict who's going to survive and who's not, which is a little grim, but it's actually a very well. Some people did. There were lifeboats. So it's a famous data science problem where you analyze the data to try to predict the results. And if you learn how to do that, there's a whole bunch of there's data science problems with bounties attached to them. Like there's this website called Kaggle, where people will post and they say, I have this database of 6 million images and I know which ones are, or what, I mean, that's a ridiculous example, but sometimes it's medical stuff. Like these are MRI scans and we want to know who has a tumor that's going to form in their brain or something. And people will post a data set with a challenge and then have a monetary bounty associated with it. So there's a lot of people that do this for fun, people to do it for money. So he's doing a short class on that. And then one of the things we were talking about is a robotics challenge, right? And one of the things we were joking about is how could we come up with a robot and have people try to escape the building, right? Like get the robot to leave the building, right? So that's actually escaping the building. Yeah, actually escaping the building is probably too tall a challenge for a 3-week short thing. But that was sort of the design idea here, where Michael, it was funny, we sort of went in the same direction. Walk downstairs.
More wheels.
We want to is tolerant of falling down the stairs, right? So you guys all met Ilya, right? So we posed the question to him, and he was like, I'm going to go figure out how to find the button on the elevator and push it so I can ride the elevator, which is actually pretty brilliant.
That's an aggressive strategy
Yes.
for a really small robot.
Well, he was thinking of his own robot. And I'm like, I want to build a robot that can fling itself down the stairs and recover. So anyway, that was sort of the idea there. So
Yeah, we'll walk wherever it is.
yeah, so there's a couple of interesting things about this robot. Let me see that model again for a second. So first of all, so the idea of any direction being acceptable is up. Like, okay, that's pretty straightforward, right? It's always going to land somewhere where it's on 3 wheels. And you guys know quite a bit about 3D modeling and 3D printing. If you take a look, that's just the battery. But the corner pieces, like this is modeled after like a 4-sided die, or a tetrahedron. The corner pieces are all identical, and the plates are all identical. So I just modeled the corner and the plates and then repeated them 4 times, and I had the whole robot, right? So it was super simple design. The motors fit into these little pockets on the tips. They just slide in, and on the inside the wires can come through so they can go to the interior.
What if it falls down the stairs and the motor just
Well, that can't. It's actually supported on the back, so it can't go in. But I'm not sure that this is strong enough to actually survive a fall. It was more like the concept. Like the wheels might break. The tires, they're 3D printed. They work really well, but they might pop off. There's all kinds of flaws, and we could iterate the design. But if you look at the guts, there is an accelerometer in here, so the thing can know which way is up, which is helpful. But that's actually not necessary. Everything else that's in here is stuff you guys have already dealt with, right? There's a Raspberry Pi Zero W running the same code as we were doing on the first robots you built, where it just controls the DC motors. Except in this case, I have 2 of those H-bridge chips that you guys were doing because I've got 4 motors. So you remember the little boards that you guys built that you soldered up? I have one in here. It's just twice as big, like twice as wide as the one that you built, so it has 2 H-bridge chips. And instead of 3 control pins for H-bridge, well, it's still 3 per H-bridge, but I've got 4 sets of them. So the code, I just expanded it to control 4 motors. That's all I did. And so now the Raspberry Pi can turn any of these motors on and off and reverse direction, right? So, and then battery and power switch, no big deal. So tell me what you think about how this move, right? Because none of the wheels are
Swing itself.
parallel to each other. Yeah, so expand that thought a little bit. Like, how do you think that would actually...
It would have to have a smart enough program that it can use one wheel to swing itself and then know when to stop and swing with another wheel.
So,
So
right.
It would look really weird going.
So I showed the drawing of this thing before I printed it to Michael, and I asked him what he thought about how it would move. I had an idea. I wanted to know what he thinks. And you remember from the AI machine learning discussion we had at the very beginning, sometimes we have machines learn how to do their own thing. We could use a machine learning algorithm and have a reward based on linear travel, like how fast it can move. And other than that, tell it nothing and be like, okay, robot, figure out how to walk. And it might come up with a way of moving that is totally unexpected to us. So, there might be multiple ways that it could move, and based on how we train it or how long, it might come up with a thing. Michael's idea was that if you take 2 adjacent motors and run them in the, I guess technically it's opposite direction, but I mean sort of in the same forward direction, it should be able to drag the 3rd wheel. Right? So the 2 wheels that are furthest away from me now, if they're rolling this way, it should be able to drag the 3rd wheel and skid itself along and go forward.
So with your balancing robot, you had 2 wheels.
Yeah,
right?
yeah.
So is there a way you could implement that into this and
Oh boy, I didn't even think of that.
Yeah.
Oh boy.
Right now.
Well, but I mean, theoretically, it
The
should be
fastest.
possible, right? Like if you could get it to move forward with enough momentum to swing itself and actually lift the back wheel up and then balance, that would be amazing.
So you just have to move forward, kind of skip a bit.
And then right, or maybe run the wheels forward and then halt them suddenly.
Yeah.
Probably also require these to be more straight, though.
Maybe.
You just put a gyroscope in it and then run it down the stairs.
Maybe. Yeah. Well, did I show you guys the Omni wheel?
The Omni wheel?
I know what an Omni wheel is.
Yeah.
Hang on. It's been so long since you guys have been here. There's all this stuff happened.
Oh wow.
Oh yeah,
3D
that hurt
printed.
my brain.
Yeah. So So that in the same conversation that Michael and I were having about these robots, I was talking about Omni because he had heard of them but had not seen, like, not held one in his hand. So I modeled that. I did that in Fusion, and so basically, again, repeating parts here. These rollers are all identical. The inside. So if you look here, there's a seam, right? So there's an inside and outside plate for each half of the wheel. So there's an inside piece and an outside piece. Yep, there's a 3D printed pin that goes through the center of each roller. And then these little metal parts are bushings. I have a whole bunch of them. And so I did put them in there so that these spun better, right? But so this is one unit that bolts together. This is another unit that bolts together. And so there's 1, 2, 3 parts, 3D printed parts, but there's just like 10 of these and 2 each of these. And it all bolts together. It's got the same nut trap that holds it onto the motor like the wheels on your robots do. So
how are these things run to go also sideways?
Well, so these roll this way. So you can roll it like the traditional wheel, but as long as it's in a position where at least one of these rollers is touching the ground, it can roll sideways. Because it's hard to see, and I have the tolerance just kind of close. This is taller than this.
Okay.
So if it's flat, it'll roll past it. If I was going to modify, like I iterated the design a couple times, do it again, I would bring this part of the model in a little bit because there's no reason it has to stick out that far. And then so basically, if this is touching the ground, then that rolls, and as soon as it rotates so that this one comes into play, they overlap, and then it'll roll on this one or roll on both of them or whatever. So the wheel can move this way or this way. Okay?
How do you like choose which way to go?
Well, that's going to be determined by a couple of different forces. So if you had this on that, then if the 2 front wheels were dragging the robot that way, this would roll on that very easily, right? But imagine if you had a square robot with one of these on each side. You could determine which way the robot goes by running these motors, and the ones on these 2 sides would roll, or by running these 2 motors, and the ones on these sides would roll. So you could have a robot that could go like this, like navigate a maze without ever turning.
That's what BattleBots, I think, the Quantum, like the pincher bot that like picked another bot up because it got stuck in the air 500 steel plating. I think it just like slid right back and forth. I think that was on New Wheels. It might have been Mechanism.
Okay, yeah.
I'll have to tell the difference in the middle of it destroying something else.
Yeah, but if you can model something like this, like I spent an afternoon on this. Like it's, like you guys have the skills to make this. If you understand the shape and you understand how it works, and you play around with assemblies a little bit, there's no part of designing this that you guys can't do, right? So you create a model like this, and you could 3D print it out of nylon. It would be super tough. You could send it off to have it fabricated out of metal. I don't know that that would be cost effective, but in this case, like the professional one, like the ones you buy for robotics, I think they're like $20 or something like that. Probably more durable than this, but this is probably $5 or $10 in plastic and maybe another couple bucks in parts. And if you need one, like because you broke one in competition or whatever, you just print another one, you know, or it might not be. And the rest of it's yeah. But like, what if you liked this, but you needed one half the size? Yeah, like maybe they might not even make that, right? Yeah. So, you know, you design your own and then you've got them. So anyway, so at some point we're going to, like Michael and I took a quick pass on writing the software for that, and we're going to train it. We're going to use the machine learning algorithms and have it figure out how to walk. And my theory is what you were saying, where the motion is going to be basically, yeah. So if you have this thing, if you run these 2 wheels in the same direction, so this one going this way and this one going this way, and you leave this one still, it should pivot around that wheel. Yeah. And so what you can do is you can alternate that movement, right? So you can do this and then do this and then do this and then do that. And so there's a lot less friction going on there than dragging the wheel. So I think Michael's idea will work. But I think if it learns it properly, this could end up being much faster.
It would work well if you replaced all of them with wheels.
Yeah, the other possibility there is it will just not move at all because like it can't get any like if the Omni wheels they just like it's like like Bambi on ice or something like that.
Just bought a little spike on the front that's durable enough it can just go straight out the window.
How about a parachute?
Yeah.
So anyway, I'm really excited about this because like it sort of came out of a random conversation, and then like a few days later the robot existed, and that's pretty cool. But I think this is actually going to end up being a super fun learning tool because either we could give this to a set of kids and be like, make it walk, and they program how they think it ought to behave. You could give it to a different group of kids who are interested in machine learning and say, teach this or have this thing learn how to walk. You could have this thing do obstacle course stuff. You could have it do positional awareness. Like there's just a bunch of different stuff. You could use the overhead camera OpenCV stuff like we did with the mini-bots and the position tracking, or you could use the accelerometer and the gyro on board for it to know how it's moved, and have it be, totally independent without a camera at all. So anyway, we're still sort of sketching out the plans, but in, I don't know, like probably second week of February. I think I might have sent out an email already. Yeah, you guys, I think the emails that I sent out go to your parents directly. If you want me to copy you on the emails, you can give me your emails if you want, but or whatever. But I think second week in and running for 3 weeks, we're gonna organize something that's sort of more like a hackathon where we have the existing robot and there's going to be a challenge or multiple challenges. We might start with getting this thing just moving. And then having a slightly harder challenge and a slightly harder challenge. So instead of like skills based, it's going to be like let's tackle a problem. Yeah, like let's tackle a problem. Either hack the existing code that's on there, write your own in Python if you want to, or whatever. And it's not going to be super rigid in how you solve the problems. Like let's say that on week 3, we had some challenge that you could tackle by doing a machine learning thing, or you could just write a program to do it. There's no right or wrong. It's however you want to attack it is totally fine.
How difficult is like programming motors in Python?
So you have code on your robots that does it now, right? Basically, it's pretty darn simple. I wrote a Python library that does a lot of the work for you, but even if you pull that open, you can see what's going on inside. And basically, it's when you were putting this thing together on the Raspberry Pi, you were running wires over to the H-bridge. There were 3 wires per motor. One turns the motor on and off. The other 2 determine how, like the direction. Actually, the one that turns it on and off sort of also determines the speed, but the other 2 determine the direction. So basically, you just say pin high or low, and then the other 2 are either high or low in alternating combinations to set the direction. So turning motors on and off is really just, hey, Raspberry Pi, turn this pin on, turn this pin off, and then turn the motor on, and it does it, right? And you just do those in different combinations to do different actions.
You must have one pin do direction, like for like off on the pin be going like clockwise and then on being counterclockwise.
Well, it's how the H-bridge is designed, right? Is you have the 2 direction pins, and then the activate pin also has PWM, so it can control the speed. But in code, you could definitely just be like forward, back, off, fast, slow. Yeah, like it's all right there. And so the way that we did the software is there's the motor control functions in Python where you can just say motor 1 forward, turn motor on. Right? So it's just commands like that are like plain English in Python, but you don't have to use that. You can manually turn the pins on and off. Like it works either way. If you're interested in seeing what that's like, you should take your thing with you and just pull the software open, right? Fire it up, get in there, look at the example code that made the thing move around, figure out how it works, and if you can't figure it out, post on the Discord and we'll talk about it. Because at this point, there's now like 15 kids that have all built these robots and have all gone through the code, and a bunch of people in the Discord write code in Python. So if you come across something and you don't know, what's that?
I don't.
You could fix that. So yeah, I mean that's the whole reason that we set up the Discord and we try to get everybody in there, is everybody can share what they're working on, and a lot of the people are familiar with a lot of the stuff that we're all doing, so we can all help each other out. Post pictures of what you're doing, post a code snippet you're stuck on, ask a question about Python syntax, ask a question about what YouTube video to watch to learn how to do X, Y, and Z. Like that's the whole point of the Discord.
So what about like, does anyone know how to code in Java?
Yes. I'm terrible at it. Michael is an expert at it. So he's like, the stuff he develops professionally, like most of it was written in Java up until recently, where they started doing a lot in Python because they were building something so that the people who are using the software could basically hack it themselves. And so they started building a lot of stuff in Python. But he's been writing Java for years.
Because I know, like, for robotics, we mostly write our coding, like,
You can
entirely
use
in Java.
Java, C++, or like
Yeah.
LabVIEW.
Mhm.
Yeah, LabVIEW, I don't think.
LabVIEW?
I think LabVIEW is like their kind of BS proprietary one.
Yeah.
It's like, we tried it for like a week, and none of our coders liked it.
Okay.
And so they're like, yeah, you know what, we'll just write
We
it
don't.
ourselves.
Also,
Yeah.
why use C++?
Because that's what it works.
Well, I mean, there's reasons that you would choose one over the other, but a lot of times,
For this kind of robot.
oh yeah, I mean, it probably wouldn't be my first choice personally.
Yeah.
Like I find Python a lot more readable and approachable, but like C++ and Arduino code and Java have a lot in common. So like, let's say that you had previously taken a class in Java programming, and then Java wasn't an option for X, but C++ was. It would be an easy transition for you. So like, there's no right or wrong for any of these
But
languages.
isn't it like widely known as like the hardest programming language?
I mean, people are going to have different opinions about that, but like, so talk about languages being like high level or low level. Like high level is like closer to plain English, and low level is closer to machine code. And a lot of times, the lower you go, the more high performance it is, because the computer stack has to do less translation. Yeah,
Oh, wait, that's
My dad.
That makes sense?
I'm doing it.
yeah.
Describing.
So yeah, for my school we have to do like a year-long project. I'm doing it on computers. So yeah, I went over that already.
Cool. Yeah. So, what was your
We were
dad
having a
saying?
discussion about like kind of comparing languages to tools.
Mm-hmm.
He was like, Python's kind of like a dull axe. Like,
Yeah, sure.
you can do stuff with it, but it's not like super dangerous to someone who doesn't know how to use it. And
Right.
C++ is like a chainsaw. It's
Yeah,
really, it's
right.
really good if you know how to use it, but it's really dangerous
Yeah.
if you don't.
Yeah. Yeah, I mean that's it. That's actually a good way to frame it too, because a lot of these languages have like protections to keep you from doing dumb things or writing bad code or like whatever. And like Python is a good example because it's super helpful. Like it gives you error messages, and half the time it either guesses what you're trying to do and fixes it for you, or it gives you a message back that is very clear in what you did wrong.
Or just shows you where you went wrong.
Yeah.
All Fusion has is Control Z.
Well, that's slightly, yeah, that's kind of it, yeah. But anyway, so if you guys are interested in sort of the hack challenge kind of stuff, you should, I think your parents both have the emails. You should take a look at that and see if you want to come back for that. And then, of course, we're going to offer something else.
Half the time it crashes before you can use it.
It all depends on what you ask of it.
Yeah, because our lead coder just graduated, and he's gone.
Ruh-roh.
Yeah, so.
Well, it's an opportunity for somebody else to step up, so
yeah,
that's
I know.
cool.
I had coded just like a little bit last year, but nothing like special.
Mhm.
And this year, like, you've seen the challenge, right?
Yes. I was.
So- Oh, okay. I wasn't able to make it to the kickoff, but yeah, we're planning to use like a lot more motors than we did last year.
Just really all the motors. We're just going to put all the motors on there.
Like, just since we're using this year, our new mentor told us, since he has like experience
Mhm.
with like the first competitions, he told us to get swerve wheels.
Okay,
And so we got swerve wheels, and each of them uses 2 motors.
okay.
So that means we're gonna need at least 8 motor controllers just for moving the wheel.
So what is that, like a drive wheel for the wheel and then steering or something?
Yeah.
Or
So it's a wheel that turns the wheel, or a motor that turns the wheel.
Yep.
And then a motor right next to it that actually turns.
Right.
Yeah.
Okay. So basically, using those as your drive system, you can move the robot in any direction.
Basically,
Yeah. Okay.
Yeah.
I gotcha.
And then we're gonna have kind of like a cannon
Yep.
that kind of picks up the balls, and then it can store them.
Mhm.
And then at the end, it's got 2 wheels that can just launch them.
Okay.
Yeah.
Are you building the cannon, or do you?
No, we build everything.
Okay.
Basically.
I think for our ball collection, we're using like screws, and it'll just like kind of suck up and pop in. Surprisingly, it's made out of pool noodle. This pool noodle is amazingly grippy.
And also cheap and available.
The balls are feel like they're like high grit dodge balls.
Okay. Yeah.
They're very weird.
Okay.
They just feel like.
Yeah.
So you're using pool noodles as the
We're
traction
we're
surface to pick it up?
Spiraling it
Yep.
into a screw, and even our prototype was we got a PVC pipe, we put it around that, taped it.
Mhm.
We then taped the PVC pipe to the head of a hand drill,
Nice.
and then put a metal rod on the other side to hold it up so it wouldn't just droop.
Yeah.
And it was like shooting it straight over what we made is the bumper, which was just like stacked metal plates.
Mhm.
It would just like shoot it straight in, and it would just climb the wall.
Wow.
Because like once the pool noodle grabbed it, it would not let go until the spinning force of it forced it up.
Yeah.
Yeah.
Wow. That sounds like a pretty cool design.
Yeah.
That's super cool.
Our team is kind of like our kind of goal is to just brute force it. So you need to get 5 balls
Yeah.
in the hexagon goal to allow you to climb.
Mhm.
So we're planning on like our indexing system can hold 5 balls,
Mhm.
and it's gonna be angled to the point where it'll hit the hexagon. So I don't know. Is there like
There's
cooldown for how often you can shoot it?
no, but you can kind of auto target it because they left 2 pieces of reflective tape on either side of the.
Oh, so you can just have
I
a
think
sensor.
I think there's 2 on the outer hexagon, and then you can just have it point to the inner one because the
Yeah.
inner one's always in the same spot.
Yeah.
But I don't think there's any sort of cooldown. Also, one thing our UNH guy recommended us, somehow he did FRC for 5 years, which I don't know how that happens.
Oh yeah. If I finish, I'll have done it for 6 years.
Did you start in middle school?
Yeah,
Oh,
because
okay.
our school is so small that we just took high school and middle school, except the middle schoolers can't drive.
Okay.
So that's
Right.
the only drawback.
No, but
Okay.
one of the things he had said that may be useful for you as well is to make it so the hopper can't actually hold 5 balls. Like make it so it can hold 4, because otherwise he's apparently seen it happen a lot that the refs will sometimes toss out flags like candy, because if you have another ball that you accidentally hit when you have a full hopper, they can flag you for that, because that's your 6th ball that you're in contact with, and you can't have that.
Huh.
Interesting. Okay.
Okay. Could you just put like some sort of mechanism to stop balls from going in after it's loaded,
Well, once
so they won't be able to call it
you're if you're in contact with it, like your robot is kind of like
next to it?
controlling it,
Oh.
it will. You can get flagged for that. Like for ours, it'll kind of be our thing will like drop down when it starts because it's in front of like the entire front of our robot, and that's why we're only gonna have 4, because it'll just kind of be on, just hoovering on balls.
Right. Right.
Yeah.
We are almost out of time. Somehow that happened. So just a couple of last thoughts. So check out the course descriptions. Please come back. I would love to have all you guys back and doing more stuff. But also, I know I say this every single.
What's the one for this class?
Say that again.
What's the non-programming one? What's the like,
So read the description in the email that went out to your parents. But basically, it's going to be 3 weeks, like 3 consecutive weeks of challenges built around that robot.
oh, okay, cool.
So.
Coding at all?
Well, I mean, part of it's going to be coming up with the idea, partnering up with people. You don't have to write code from scratch. You can hack on code that's already there. Like, don't have a preconceived idea of what it has to be. Like, come up with your own idea on how to work around it. That's part of the challenge, So anyway, so there's that. I know I mentioned every single class about independent projects, but please think about things that you might want to keep working on and use this place as your resource. And keep coming to the Discord. even after the class is done. Like, tell us about your projects. Keep working on stuff. Ask us for help. If you want Michael or me to drop by on one of your robotics meetings sometime and give you guys some input, or if you need help getting over a problem or you have a programming issue or whatever, like ask for help. I'd love to come and visit you guys at UNH.
Our mentor, our new mentor, is like, he was a lead coder, but
Mhm.
we feel like it's not really fair if we use our mentor as kind of our main coder.
Right.
That can work too, because two of our mentors are both software developers.
Yeah. Yeah. Right. I mean, like, if part of this is exposing you guys to problems and making you work through them, like, there's a point of view that is, like, the people who are doing the job should be the people who, like, would benefit most from the challenge, Like, obviously, it's competitive. You want to put your strong people in there. But, like, you don't want to just play to people's strengths. And you got to think about what next year is going to be after people graduate and who's going to take up new stuff and all of that. So, anyway. Cool. Also, if you guys want to take your robots with you, like if you want to keep working on that stuff, grab your bins, take them home. When you fire those up at home, they'll do the advertising, the wireless access point thing, just like they did here. So you can connect to them and work on the code and all that stuff. So.
I don't know how to fix the problem I have with that.
Okay.
Because no matter that other thing that you tried suggested did not work. It just deleted the whole thing again.
Okay. So the next thing I would try is modeling the egg-shaped thing as a separate part, and trying to. Oh, I thought you were still. We'll take a quick look at it, but oops. Can you? But we might need to move the discussion back over to Discord so you can keep working on it at home. So, yeah, what I meant was start a new design and create just this part and try to get the dimple pattern thing to work, and then we can import that part back into here once we've got the dimple things replicated. So if you go over to your models here, yeah, you can just do it that way. And try to create that part again with the same dimensions that you've got in the existing model. And because that model is much simpler than the whole thing altogether, Fusion may struggle to do the pattern of those dimples around the thing. All right? So give that a try. And let me know how that works.
Because we know one of the people on my team does SST, and he does like a lot of soldering work and that type of stuff. So we're planning to have him like do some like heavy soldering on that thing, and he also has access there to plasma cutting. So we're planning on plasma cutting some pieces out.
Nice.
Yeah.
That's super cool. Do you want to take your robot parts with you, or are you cool with that? I mean, you can take it with you if you want. Okay. So I had sent one of the things we were talking about is we've got another short, like a 3-week run. That's a totally different thing. I had sent an email to you and to Kevin. Thank you. Sorry, I was spacing there for a minute. So if you could pass that along and you could take a look at it, that'd be cool.
When did this start?
I think second week in February. Cool. Good to see you. Have a great night, and see you on the Discord. Cool.
You'd probably actually be super interested. There's like a printer there that is like the no touch in the room. it's like $1 million like multi-material 3D printer.
Oh wow.
Like
Is it like a Stratasys something?
I have no idea. They put like a kind of roll-in wall up around it.
It's so funny. I really want to in the last couple of years, they've made a lot of advancements in metal printing, and there's a bunch of different technologies from sintering particleized metal, and then so you get something that's fused metal but it's porous, fuse it all together, so there's a post process. But then there's also machines that will basically, it's like a welder, where it sort of works like a 3D printer where it welds the shell of a part, and then they use a multi-axis CNC to machine it down to tolerance. So there's a different approaches. I've never been able to get hands-on with a metal printing machine yet, and I would really like to find somebody who's got one so that I can play around with that. somebody just recently came up with this kind of a neat system where they basically developed a special 3D printing filament that is stainless steel particles suspended in a binder, and you print it on any standard 3D printer, yours, mine, whatever, and you print the part and you oversize it by like 19%, and then you ship it off to a post-processing facility, and they melt away the binder, leaving just the fused metal, and then they do that sort of wicking thing. And then they send you the part back, and the shrinkage is so predictable that the amount that you oversize the part gets reduced back down, and you get a dimensionally accurate part in the end. And the way that they solve the problem of the post-processing that you can't do yourself because you need like special ovens and all this kind of thing is you buy basically like a coupon that's good for like 2 kilograms of post-processing parts. You pay like $50 for the coupon. You pack all your parts up in a box, ship it, and they post-process it and ship it back. And I was like, oh, $50 for 2 kilograms worth of parts. That's not too bad. What I didn't realize until I actually went to actually get some of the stuff to try it out is the filament costs like $350 a spool. So
It's like carbon fiber.
yeah, so we'll get there someday, but like I still don't have it would change my approach to things a lot if there was a way for me to 3D model a part and then print it in metal, you know.
Yeah, 'cause, like, there are printers that do it, but all of them cost like $100,000.
Right.
The like Mark IVs or whatever.
And I can't like have them in my house. Like I need them in like an industrial setting because there's fumes and there's high heat and huge power requirements and all of that kind of stuff. So
Like probably the most prominent example of the metal 3D printing would be like the Savage build show. I don't know if you saw that at all.
Yeah.
The episode 1 with the titanium Iron Man.
Yeah. Yes.
Which is definitely a good pilot episode.
Yeah. That's good TV right there.
Go to like the only place that had it like in the entire country was like a university that's like metal processing and mining,
Yeah. Right.
and they're the only place that can do that.
Yeah.
And it costs like $1 bajillion.
Right. But high budget TV show, so they get to do that. Anyway, so post on the Discord and let me know, like if maybe we could come and visit one of your meetings or something like that. Like it'd be cool to meet the team and like see your lab and and kind of hear what you're working on and all that. What's that?
We do like Tuesdays and Thursdays from 36 and then Saturdays from like 3 to 7.
Cool. Michael and I work on the LoisLab, so. That'd be super fun. Thank you.